2, we will take a break, okay, a 5 to 10 minutes break. I will come back to you and let you know what are the questions that we will discuss. But before that, you will have to try the question first. Okay, I will let you know later after the break. Okay, at the same time, I need to update your attendance firm. I need to update your attendance first. Then only I give you the attendance form to fill up for this tutorial. Okay, students, I have just attached the attendance form to you. Okay, please fill out the form for this tutorial. Okay, students, I am sorry. I just remember to upload the tutorial to you in Google Classroom. Okay, you can now go to Google Classroom to download the tutorial tool. Okay, and then you have to try a few of the questions that I circled. Okay, you can see from the screen uh, the questions that you all have to try is question 4. Okay, question 4, 5, 7, 9, and 10. Okay, there are 10 questions in this tutorial too. Okay, I want you to try the 5 questions that I have circled here. Okay, later I will write in the chat box if you cannot follow which questions to try. Okay, but here there are 5 questions. Question 4, 5, 7, 9, and 10. Okay. Also today I will give you half an hour to try these 5 questions. After that, I will discuss the answer for these 5 questions. Okay, and then I also need your answer. Okay, I want to check whether you can answer all the questions. Okay, please try all the questions during the class. the questions here is the 5 questions that I mentioned just now. Okay. Okay, students, I want to check with you. Have you all finished the questions? Okay, now already over half an hour, so I want to discuss the answer for all the questions. Okay, so I will discuss the questions with you. Okay, we only have 15 minutes left. Okay, so for those who are able to answer the questions, you have the answer, you can actually let me know. Okay, I will need you to answer me, okay, with your answer. Okay, I want to know how well you can answer and solve the questions. Okay, uh, now I will start with question 4 because I asked you to try question 4. Okay, question 4, define the meanings of masses in CMOS fabrications. Label each of the masses in the following based on the inverter cells layout given in figure 1a and the cross-sectional area of the inverter in figure 1b. Okay, so for this question, it is an easy question. Okay, if you are able to understand what is given in this figure 1, then you will be able to identify what are the layers that are being drawn in this figure. Okay, so for part A, this is a layout design of an CMOS inverter. Okay, so here there is this line. Okay, this is actually for you to fill up. Okay, so what is this? Okay, if you know how to answer, you can just answer. You can answer me. Okay, contact. Yes, contact. Okay, Ji, you mentioned you answer. You give the answer at the metal. Okay, metal is not correct. Okay, I start with this one. I start with this, the black color square box. This is contact. Okay, this is contact. Okay, so contact, if you answer contact is correct, then how about the next one? This one? Okay, so this is metal. Okay, then next one, metal is correct. Okay, then this one. Okay, so okay, G give all the answer. Okay, others. Okay, this is P diffusion, P plus diffusion. Okay, so I think you all have the same answer. Okay, P plus diffusion, and this is N plus diffusion. And this is polysilicon. Okay, so if you have this answer, means that all correct. Okay, and then there is another diagram here in part B. Okay, this is a side view of a CMOS inverter. Okay, this one you also need to label. Okay, so what is one? The first one, what is this? What you all have answer for this? Source terminal, drain terminal, ground, or VDD? How do you answer this? Or you are not sure? Okay, so this one is a M plus diffusion area. Okay, there are two areas here. Okay, and then this one means that they can be source or drain terminal. Okay, but this transistor is actually NMOS transistor because there is an N plus diffusion area. Okay, so here normally these terminals will be connected to ground. Okay, and then this could be the source terminal. Okay, and then this one, as you see that this N plus, the terminal is connected to another terminal here for the PMOS. Okay, so this one is the output. Okay, the connections here can be the connections to output. Okay, so here number 3 here show this part. Okay, this part is not this part, this part. Okay, the blue highlight. Okay, so this one is the output. Okay, this one is output. This is Y. If we want to match this diagram with this layout diagram, okay, we can say that this is Y. Okay, this is Y. Okay, and then for number 2, this one is showing the gate here. This is gate. Okay, this is gate. Gate means the polysilicon, that mix of polysilicon layers. Okay, so this one is polysilicon layers. Okay, this is A. Okay, so what you have labeled here, you need to relabel it here. Okay, with the appropriate one. Okay, which indicate by the arrow here. Okay, and then this one, okay, and next one is 4. This one, number 4, shows the terminal P plus diffusions area. Okay, this is the source terminal as well for PMOS. Okay, and these source terminals of PMOS usually is connected to VDD. Okay, this is connected to VDD. Okay, and then number 5 here, it is indicate to this area. So all of you know this one is the P plus diffusions area. Okay, and this is N plus diffusion. Okay, so all of these are as easy as that. Okay. Okay, so part B, no problem. I see that you can give the answer. Okay, G has given him his answer. So all of you also, I think you can get it. Okay, so question 4, no problem. Now I goes to question 5. Okay, question 5, briefly discuss why the layout design rule is important in the IC design before fabricating the integrated circuit. Okay, I mentioned this to you before. Why the layout design rule is important? Okay, there are a few reasons. What is the answer that you give? Specify the minimum spacing and dimension. Okay, yes, it specified the minimum dimensions and spacing. And why the minimum dimension and spacing need to specify? You need to further elaborate. As to say, you need to give more. Increase designer efficiency. Yes, correct. And then some more. How about the functionality of the circuit? Allow translations of circuit into actual geometry in silicon. Yes, this is also uh, one of the point. Okay, there are a few more which you can include. Okay, the reason why layout design rules is important. So just now, three of you have give the answer, so they are correct. Okay, but you need to give the complete one. Okay, the complete answer is the layout design rules are needed to achieve better area efficiency, better yield, better reliability, increase the probability of fabricating a successful chip product on silicon wafer. Okay, so this one you need to mention as well. Okay, and then if the design rules are not followed, okay, then what is the consequences? You also need to write. You also need to give the consequences. Okay, the answer here is if the design rules are not followed, then it will cause non-functional circuit and the design consuming larger silicon area and the device can fail during or after simulations. Okay, this is also important. You need to include. Okay, so that is the answer for question 5. Okay, so now I goes to question 7. I see that we don't have much time. Okay, I will take another 5 more minutes. I hope I can finish within five minutes. I try. Okay. Okay, question 7. Okay, consider a layout design is applying 4 layers and above using deep rules for schematic and physical verifications. Determines the spacings between the metal 1 to metal 1 and the spacing between the P active to N active. Okay, so for this one, um, I have mentioned to you before in lecture class. Okay, there is a table that I have given to you in the lectures notes. Okay, the lectures notes given, um, you can refer. Okay, you can refer to the table in the lecture notes. Okay, the table show all the spacing, width, okay, from one layers to another layers. Okay, so for this one, what is the answer? Are you able to identify what are the spacing? Okay, remember that the design rules that it use is the deep rules. Okay, and then you have to refer to the column for the deep rules. Okay, maybe I will show you here. Okay, if you are able to get the answer, you just let me know so that I know what you can get there. Metal to metal 1, 3. Okay, active, P active to N active 4. Okay, looks like correct. Metals to metal 1, 3, correct. Okay, and then 4. Yes, that's correct. Okay, so you know where to get the answer. Okay, good. That means that you pay attention during class. Okay, then how about part B? If the spacing between the polysilicon to the active area and P active is 2 in this design, determine if it will pass the DRC. Okay, is the spacing given here correct? From polygon, for polysilicon to the N active and P active. Okay. Okay, now I show you the table here. Okay, so the answer you can actually get from the table here. Okay, if you are able to answer question part A, then you also will be able to answer question part B. Okay, part B is the spacing from polysilicon. Okay, spacing from polysilicon to active area. Okay, active area can be P active or N active. Okay, if you refer to this table, okay, this row, poly in rules 3.5, spacing of poly to active. Okay, the deep rules is 1. Okay, deep rule is 1. So the question given to you, the spacing is 2. So it means that it will not pass the DRC. Okay, it will not pass the DRC because the spacing is incorrect. Okay, because it will have to be, let me see, spacing of poly to active is 1, so it's 2. Let me see, I think it's correct. It can be. Okay, just now I think I say wrongly. Is minimum is 1, so it will pass. Okay, okay, so I make a corrections, it will pass. Okay, because this one the minimum spacing is 1, so the spacing given here is 2, means it is more than 1, so it will pass. It is correct. Okay, it is correct, it will pass. Okay, so all of you, you get the answer. Okay, part B, it will pass the DRC. Okay, and then now I goes to question 9 and 10. Okay, it's almost time. Should I continue or I just stop here and continue in the next class? Are you all still okay there? Okay, so two persons say okay, then how about others? If others no respond, then I assume that okay as well. Okay, okay, good. So I continue. I finish the two questions here. Okay, question 9. Assume the schematic diagram of a logic gate is designed using electric. The design rules check DRC, electricals rule check ERC, well check and network consistency check NCC are required to be performed to verify the correctness of the design before it is being stimulated. Justify if the statement is true in the schematic verifications process before a layout design is drawn. What do you think? Is the statement correct or not? Okay, this is about the schematic diagram. Okay, after the schematic diagram has done, okay, it needs to be verified using DRC, okay, and ERC and also NCC. Okay, from your experience, after you draw the schematic diagram, does all these three checking needs to be done on schematic diagram? Okay, maybe I give the answer here. Okay, and then you check later. Okay, for schematic diagram, uh, only the design rules check and NCC can be performed. Okay, only design rules check and NCC can be performed for schematic diagram. Okay, only this one. Change the color. Okay, only design rules and NCC need to perform. ERC, no. Okay, for schematic diagram. So this statement is incorrect. Okay, why is incorrect? Because for schematic diagram, electrical's rule check does not necessary. Okay, it only perform on layout design. Okay, because ERC perform wheel check, not okay, okay, not wheel is well. Okay, sometimes I mispronounce. Okay, perform well check. Okay, and then this well check is only on layout design. Okay, in layout, there are P well and N well. Okay, in schematic diagram, there is no P well and N well, only wire and other components. Okay, but there is no P well and N well. So there is no need to perform the well check. Okay, so I hope you are able to differentiate. Okay, for the DRC, ERC, and NCC, some of the diagram they does not need to perform ERC. Okay, only on layout design, ERC is needed. Okay, and okay, for both schematic diagram and layout design, we need to always check using DRC, design rules check. Okay, and also NCC. Okay, so this is the answer for question 9. Okay, now I goes to the last one, question 10. Okay, identify the errors that would cause from design rules checking as shown in figure 2A and 2B based on the direct observations without the use of any software. Okay, so from these two layout design, okay, there are some error. Okay, in part A, uh, what is the error that you can detect? Which part? The layer, the spacing, the width, width more. Okay, width. There no problem. Okay, the width likely is not the width problem. Okay, because the width is always fixed if we didn't manually manipulate if we didn't manually change it. Okay. Okay, which part that you can detect? This part? Is it this part? Okay, I label here. You just tell me which part do you think got problem. Okay, this is part 1, part 2, Part 3. Which one do you think got problem? Part 1. Okay, yes, correct. Part 1. Part 1 spacing. Which spacing? This spacing? Okay, I erase this. So all of you, you identified part 1 as the error. There is an error there. Okay, what? Okay, someone space this. Say the spacing. Okay, which spacing? This spacing, this spacing, or this spacing? Horizontal or vertical or horizontal? Okay, so you answer part 1 is correct. All of you correct. Okay, just that. Oh, what happened? Horizontal. Okay, horizontal means this one. Okay, so you all mentioned that this spacing right, horizontal. So means that we need to move this contact to further away. Okay, just look like this one. So this is the error. Okay, so it's correct. Okay, in part B, how about part B? This part B. This one, which part is got error? Okay, maybe some of you, you can see that, okay, there is a metal layer here, the extended one. Okay. Okay, so this extended metal layer actually caused the error. Okay, the error here is actually not caused by having this metal layer, okay, but because of the spacing here. Okay, if we move this layer to further away from this metal layer, okay, this will not cause an error, no error. Okay, but now the metal layer here, because it is too close to this layer, to the active area and also the metal layer here, so this cause error. Okay, so I repeat again, the error here is caused by spacing. Okay, it's not caused by the additional metal layer. Okay, it's not caused by this, the extensions of the metal layer, but because of the spacing. Okay, if we want to maintain this metal layer, okay, this metal layer, we should move this further away from the active area. Okay, if we move this further away, likely there will be no error. Okay, but of course, if we want to keep this metal layer, we need to make sure that this metal layers has some connections to others component. Okay, so these are the error that we should detect from this figure 2. All right, so that is all the discussions for today's tutorial. So for others questions which I didn't ask you to answer, I didn't ask you to try, please try when you are free. Okay, and all the question there is not difficult to answer. Okay, you will be able to answer if you refer back to the notes or any other reference book. Okay, so now if you all have no questions, questions, I think we can stop here. Okay, I have updated all of your attendance. You can check in your apps. Okay. So, okay, so I will see you on Wednesday. Okay, thank you to all. We can dismiss class now.